Hello, welcome to the first video in a series of videos on this channel where I'm going to be showing you how to make a maze solver in Python. Now, if you are new to Python, that is totally okay. I'm going to be assuming though that you do have some base level knowledge of coding or programming in general, whether it be from a language like C++ or JavaScript or something like that. You'll be able to follow along fairly easily. I'm not going to be too heavy on the syntax and teaching all that, but it won't be hard to follow if you have previous experience. I'm more so going to be focusing on a lot of the main ideas and programming concepts I like to implement into my code, as well as some algorithms that I'm going to be using to actually solve the maze. This is going to be a series of videos, each video focusing on a new topic, whether it be a feature of Python or a specific part of implementing the maze solver, and it's going to be incremental. Each video is going to be fairly short. So with that, I would like to show you the actual final product of what we're going to build together, and then we'll get to learning. So at the end of the series, this is going to be what you will have as a final result. A little program here that opens a window, draws a maze, and then solves it from green to red, the shortest possible path. This is not hard-coded, obviously. There is a lot of logic here that is actually solving the maze, and you can give it any maze, and as long as it's solvable and possible, it will be able to solve it in the shortest path every single time. So yeah, I do encourage you strongly to code along with me because that is how at least I remember best when I'm practicing and learning new things. So why don't we get started, and I'll break down this problem into a bunch of little pieces so that we can begin coding all the little bits. Alright, so for this video, I'm actually not going to jump into the coding quite yet. I want to walk you first through my thought process on how I'm going to take this really big problem of making a maze solver and just break it down into smaller parts so that we can actually work through how to solve each bit by itself, and then we can combine everything together at the end. The first thing I'm going to do is I'm going to actually come up with a list of constraints for myself. So I want to have a better understanding of what this problem is and the things I need to solve. So we're going to start with some constraints here. And the first thing I can think of is that it needs to be graphical. So obviously we can see here that there's a window that you can actually move around, and it has colors, and it has the maze drawn out, and it has a path from start to end. And I want all of that to be available to anyone using this so that they can see what's going on, and it's not just a console log with a bunch of numbers, nothing like that. We want some really good graphical interface here. And so graphical is our first constraint. Our second constraint is that it needs to be timely. So we don't want to hit enter or run or whatever and then have our program loading and loading for years trying to find the best solution. We want it to be able to find that solution fairly quickly and then display it to the user. So time is of the essence here. We know we also want it to solve this type of maze only. So I'm going to say boxes. We don't really care if it solves those other types of mazes like the ones with circles or rounded edges or curves or 3D mazes or anything like that. We only care if it's solving a maze in 2 dimensions with these boxes representing walls, and that's all we really care about. We also know that it needs to find the best path, and by that I mean the shortest path, the fastest path, however you want to think about it. The path from start to finish needs to be as short as it possibly can. I don't want it taking a bunch of wrong turns or loops or anything like that. It needs to go from start to finish, and that is it. So with these constraints in mind, let's actually get into looking at how we're going to tackle some of the problems of how to store the data. And by store the data, I don't mean in a database or anything like that. I mean, what are the data types we are going to use to be able to store and use the information required to solve this maze? The first thing that comes to mind is the maze itself. How are we going to store this? What's it going to look like? If it's not obvious to you yet, that's totally okay. My first idea, though, is that we're going to need a 2-dimensional array. If you've heard an array before, like any other language, like JavaScript, let's say, it's just looks like this usually, with an open bracket and a closed bracket with some elements in between, and in this case it's numbers. Sorry, I'm drawing with a mouse. And this is just an array, and then we can do all sorts of things with this array. We can add to it, we can take away from it, we can grab by index. So let's say this is the 0 index, 1 index, and the 2 index, and we can grab elements accordingly. So let's say we wanted to grab the 2, we might use the syntax of, let's say this is its own variable, a is equal to that, and then we wanted to grab the 2. So we would do a of 1, and we do 1 here because, again, this is the 1 index. It's 0-based indexing. And this would equate to 2. So that is very helpful already. Arrays are super great and super helpful. In Python, they are called lists, so I'm going to be calling them lists from now on. And why do we want to use lists for the maze in particular? Well, because I think they represent really well the rows and columns. So each row has what seems to be an empty space or a wall. In this case, it's a 10 by 10, and so we have the first 3 spaces are space, 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 and then a wall, and then the starting point. But you can think of it as a space, and then space, 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 space. And so we just had one wall in the first row. In the second row, it would be space, 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 wall, 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 space, space, wall, space. And this is another thing we can notice about this is that it actually seems to be binary. So it's either 1 or 0 or on or off or space or wall. And that's going to give us another clue about what kind of data we need to store the maze. But for now, I know that I want to at least store a list of wall or not wall. And not only that, I want to store a list of lists of wall or not wall. That is because not only is there just one row, there's a bunch of rows, and we're going to need to store all of them together too. So for this project, I'm going to be using a list of lists of walls or not walls. And it's going to look something like this. So we have the outer list here, and this outer list can represent all the rows, and the inner lists here are going to represent all the columns. And you'll see what I mean here. Let's actually say it's dot, dot, dot. So this can be as big or as little as we want, but let's say this outer list represents the rows, and the inner one represents the columns. That's because each square here is, like, let's say this top row is just one list, and it's if we were using ones and zeros and the spaces were zeros, it would be 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. And so that's all data that is grouped together in one list, and then each index of that list would represent one column. So if you get a bunch of them together, you get a bunch of columns and a bunch of rows. So that is why we're using a list of lists. The first one would maybe have that, and then the second one would have the information for the second row, and then the third row, and so on and so on. To access this information, let's just set this equal to A again, and we could use A, and then the first number here would be to get access to what row we want. Let's say we're trying to aim for this endpoint, this red one here. We have 0, 1, 2, 3, 4, 5. So we're going to grab the 5th index here, and then right next to it, because this returns a list in and of itself, and right next to it, we're going to grab the 0th index because it's right on the edge there. And so with just this simple syntax, we can grab anywhere on the board we want. And so for that reason, we're going to be using a list of lists of wall or not wall. And when I say wall or not wall, let's actually get into what kind of data that is, because the first instinct might be to use Boolean, true or false. We have a built-in data type called a Boolean that might be able to take care of this for us really easily. True or false, true or false, true or false for every single bit here. And that is totally acceptable. We can totally do that, and we can get this to work just like that. But there is something to consider for maybe something else. And that is the fact that we have these start and end points, which are already different, and we have a path going between the two. Now the path maybe doesn't matter so much because it can be stored in its own list, but the start and end points, those are made when the maze is generated. Those are set in stone. They won't change. It's not dynamic data. And so we probably need a way to store those, and it would be very convenient if we could do it in the actual maze variable itself. So instead of using true or false, which only gives us 2 options, I recommend that we use something like numbers. Let's say every space is represented by a 0, every wall is represented by a 1, and the start point is represented by a 2, and the end point is represented by a 3. Obviously, these numbers, they don't have to be like this. It can be whatever you want. We don't have to use numbers even. We could use strings or single characters. So let's say every space is represented by, I'm not sure, let's say an A. Every wall is represented by a B. The start point is represented by an S, and the end point is represented by an E. We can do anything like that, but it would be very helpful as if we had a little bit more than just true or false to work with here, and I hope you can see why. But anyways, with this in mind, we can actually have enough information to start defining a maze in Python. So that's what's going to happen next video. We're going to jump in and start defining a maze in Python using a list of lists of wall or not wall. And in my case, I'm going to be using numbers. And so I'm maybe going to represent a space with a 0 or something like that. But I will show you how to do that and what that looks like exactly in the next video. So stick around, and thank you for watching this one. I'll see you in the next one.